Welcome to the Semester 1 Final Review Packet Answer video. Unit 1 deals with trigonometry and the Pythagorean theorem. So, for problems number 1a and b, we need to use the Pythagorean theorem to find the missing side length. So, recall that the Pythagorean theorem is a squared plus b squared equals c squared. A and B are the leg lengths, and C is the hypotenuse. So for this problem, it doesn't matter which you pick for A, 8 or 15. I'm just going to put A as 8 and B equal to 15. So 8 squared plus 15 squared equals x squared. So I take my calculator, 8 squared plus 15 squared, and I get 289. So 289 is equal to x squared. Now, since we're dealing with lengths, we don't need to worry about the negative root. So let's go ahead and type in the square root of 289, and we get 17. X is 17. For number 2, we notice that the missing length is one of the legs. So now I'm going to pick x as my A, 16 as my B, and 39 as my C. So x squared plus 16 squared equals 39 squared. So 16 times 16 is 256. 39 squared is 1,521. So again, solve this. I'll subtract 256 from both sides. And we get 1,265. Take the square root. And x is approximately equal to 35.57. For number 2, we are finding missing side lengths and angle measures using trigonometry. So let's recall our three trig ratios. So notice that each of these equations have three unknowns: an angle measure and two side lengths. So when we look at these problems, we want to find the equation that deals with the two side lengths we know and the side length we're looking for. Since we know an angle, we might as well use it as the angle for theta. So if 38 degrees is my theta, that means x is going to be the opposite side because it's opposite of the 38-degree angle. 26 is the hypotenuse. So looking up here, we see that sine uses opposite and hypotenuse. So we write our equation. The sine of 38 degrees equals x over 26. So to get x by itself, we'll multiply both sides by 26. And our answer is approximately 16.01. For B, we're looking for theta, an angle measure, and the side lengths we know are the opposite side and the adjacent side. So looking at our trig ratios, we see that tangent involves both opposite and adjacent. So tangent of theta equals the opposite side over the adjacent side. Now, when we know any of the three trig ratios, we're going to use the arc or inverse trig function. So we won't use tangent, we'll push second tangent and go ahead and type our ratio. So we see that theta is approximately equal to 40.91 degrees. Number 3. In this problem, we have three things to find. Angle A, the measure of it, and then AB and BC. Let's first start with the easiest, angle A. So if you remember from geometry the triangle sum conjecture, the sum of the measures of the three angles in any triangle is 180 degrees. Now remember that this little symbol means that that is a 90-degree angle. So if I take 180 degrees and I subtract the two angles I know, that will give me the measure of angle A. And we get 32 degrees. So I'm going to go ahead and choose AB to start off with, and I'm going to call that length X. So if I use the 58-degree angle, I know the opposite, and I'm looking for the hypotenuse. So I'm going to use sine again. But when I write the equation, it's going to look a little different, because the opposite is 13, and we don't know the hypotenuse. So a common mistake at this point is to multiply both sides by 13. But if you do that, you end up getting 169 over x over here, and it doesn't get you any closer to really solving the problem. So one way you can do this is you could put 1 under the sine of 58 degrees and solve this like a proportion. So 1 times 13 is 13. And then here we get x times the sine of 58 degrees. So to get x by itself, we'll go ahead and divide both sides by the sine of 58. And we get about 15.33. Now remember that the hypotenuse is the longest side of the triangle. So if you got a number less than 13 for AB, you should automatically know that you made a mistake. So now for BC, I'm going to go ahead and call that length Y. I'm going to do it down here on this graph paper here. So if I use the 58-degree angle again, I still know the opposite, but now I'm looking for the adjacent. So opposite and adjacent is tangent. Tangent of theta is opposite over adjacent. So for this problem, we get tangent of 58 degrees equals 13 over y. (13) equals y times the tangent of 58 degrees. So go ahead and divide both sides by the tangent of 58 degrees. And we get about 8.12. Okay, number 4. Find the distance between the 2 points I gave you. Now, you could graph them, make a triangle, and use the Pythagorean theorem. But I'm just going to show you how to do this with the distance formula. So we're going to go ahead and label our points x1, y1, x2, y2. Now we'll go ahead and substitute them into the equation. So I get 7 minus negative 4. So that's the same thing as 7 plus 4. And then I get negative 2 minus 10 for my y2 minus y1. So I get 11 squared plus negative 12 squared. Now, here's a place where you need to be careful. If you type in 11 squared plus negative 12 squared, this is going to give you not only the wrong answer, it's going to give you an error, because your calculator thinks you want the opposite of 12 squared. I push enter, and I get a non-real answer. So remember that you need to put the negative number in parentheses and the exponent outside of the parentheses. So I'm not going to do the radical first. I'm just going to go ahead and evaluate what's on the inside. So 11 squared plus negative 12 squared is 265. Then I'll go ahead and take the square root of that. Sometimes it's easier to do it in 2 steps than 1 step. And I get, oops, that was cute. Let's try that again. 265. And we get about 16.28. Unit 2 problems will be on the next video.